Okay, here we have solids in contact 2 from T4, T4.E. You can get this worksheet. So, photograph of the potpourri holder, and stand is shown. The shape of the holder is based on an inverted right cone. And the inverted right cone basically means that it's generated using a right triangle spun around an axis, and that will give us a cone. The inverted cone fits into the circular hole in the holder. So here we go. We have the elevation and plan of the holder. We have the elevation plan of the cone. The drawing shows the projections of the holder and the stand apart. Complete the drawing by drawing the elevation and plan of the assembled unit. Okay, first off, I need to figure out what diameter this hole is. I can see it here, but I need to know how far that apex of that cone is going to be once it is sitting into that hole. So what I'm going to do is I'm going to actually take this diameter, I'm going to draw it onto here, but I don't have the center point here, so I need to find that center point somehow. I suppose it's fairly easy. I could just measure the base of this right triangle. So there we go, it says 28 millimeters. So if I measure down 28, I can find that. Another way I could bisect. I'm just going to do it a quick way today. Yeah, so 28 would be 56, that's correct. So 28, there we go, center point just there. I'm now going to take whatever radius this is, and I'm going to step it off onto this plan view just over here. So I'm going to take this radius just there. You can see that. And step that off here and swing a nice little construction. Okay, now I can take that and project it up and find the distance it would be from here to the XY line, basically, because I want to find how far up off the ground this will be. Then I can start constructing it. I need to find that vertex basically first, find the right triangle, and then I can construct the object. So now I have this point here. I know how high I can measure now above this, so that's how far up this is going to sit. So if we can take this height 1 here, I can step that off now on top of this candle holder. Like so, take that height and step it off. There we go, and I'm going to draw a nice horizontal line. I can then draw the base of that inverted cone, because I know the radius is 28 millimeters. The baseline then has to be 56. There we go, the inverted cone symbolizing the glass. Here we go. So I have, let's label this A, B, and I'll call the vertex V. So I have A, B. Now I need to find V. To do that, all I have to do is take the height of this, or the altitude of this inverted cone, which will be that altitude there. If I move my hand, you'll see. I'm going to take that altitude from here to here, and then I'm going to step it off from here down to find the vertex. There we go. I can now create my construction. So I can join V back to A, B back to V, they actually line up, so I don't need to draw anything there yet. That's going to be the exact same. I do, however, need to find out this diameter here. So I could just project it straight over, because I think they're in line. Yes, they are. So I could just bring that straight over, like that. There we go. And I can use my compass. Set it to whatever that is. There we go. Project it back up. I now have this point and this point over here, up here. There we go, there and there. I just need to measure this depth. Well, I know actually it's going to be the same height as the vertex. So if I come across at the vertex in a solid line, there we go. And now I just need to heavy everything in. And up we come. Actually, that goes down further. And to there. There we go. That exercise complete. We just need to define these heights, step it off, and work it out. So I took this height here, stepped it off from here, because that's what radius, how far down that cone would have sat. Hopefully you get that. Thanks.